Being able to interact in a world gives to the game another level of perspective. Interaction system lets the player use things such as door, pick up items, talk to NPCs or receive quests from them, loot, and much more. Essentially, it brings life into the game. So, let's create an interaction system. We have freshly created a project out of the third-person template with starter content. First thing, let's create a widely used function, which you might already know, called raycast. And because I might use it later in other different classes, let's create it in function library, which let us call functions in it from any class. Create a new folder and name it libraries, because I will probably create more than one function library. Right-click and under Blueprint, select the Blueprint function library, which I name Tracing, and open it. Name automatically created function raycast. Add line trace by channel, which will execute right after calling this function and leave space for calculation. Now we add input parameters. First one is start point, which is vector type. This represents point from which the line is traced. Second one is rotation of rotator type, which tells the direction of tracing. And the last one is trace distance of float type, which indicates how long the line will be. Connect start point to start and create a reroute node by double-click. Drag out rotation and search for get forward vector, which magnitude is 1, so out of it search for multiply and multiply it with trace distance. Multiplied vector would currently start at word origin, which is 0, so we move it by adding to it start point vector. We can also add some input parameters of line trace as input parameters of raycast function, but this is up to you. I might use actors to ignore, but I will definitely use draw debug type and draw time. Move to the end of line trace and add return node. Drag into it out hit and return value and hit compile. I also sometimes forget to set up values, so I set the default values for draw time and trace distance. Now let's implement it to the blueprint of player character. Go to third person, blueprints, and open PP third person character. First, I just change two things in the viewport. I want to have clear view on the object I'm looking at, so move camera boom to 100 units on the z-axis and set target arm length to 200. Switch to event graph and move down under default events. Here create custom event, which I name loop for info, and add raycast function. Drag in camera boom and out of it search for get word location and connect it into start point. Now drag in flow camera, search for get word rotation and connect it into rotation. Trace distance is up to you, I go with 500. I change draw debug type to for duration and leave draw time at 1 so we can see that it works. After raycast, add delay with duration of 0.1 and create infinite loop, at least for now. Function is done for now, but we also need to make the initial call. Go to event begin play and to the end add call to loop for info. Hit compile and test it. You can see that line starts above the head and it takes rotation of camera and not the character, just as we wanted. Now let's create some UI. Go to Content folder and create new folder Widgets. I always go with Azure Color for widgets. In it, create a new widget. First, I'll create a bordered box that I'll use across multiple UI elements so the yearly design is consistent. I name it A_bordered box. I will show you later why I used prefix A. Open it and dock it. First, add a border. This size doesn't matter, so we don't need to adjust scale. Under Draw As, select Rounded Box. Rounding type change to fixed radius and all corner radiuses set to 25. Set width to 5. Set the color which suits your game best. I set outline to black color and alpha to 1. I set tint to slightly above black, you can see exact number on the screen, and set alpha to 0.6 so it's slightly transparent but not too much. If we want to use this widget in another one, now it can't have any child components, which we want. For this usage, add named slot. Name of it is text which will appear when this component has no child, and you can use it to remember what you want to do with it later without opening this blueprint, so we can rename it to something like @item. Set padding to 0 for now. As you can see, padding is value which have both components the same. Now hit compile. Create new widget, WBP_HUD, and open it. Add canvas which represents player's screen. First, I want to add small middle point so players could aim exact object to which they want to interact with. Add image, rename it to IMG_center_point and change anchor to center. Set both positions to 0 and alignments to 0.5 so the center of image is in the center of the screen. Size is up to you. I go with 4. Set Draw As the rounded box and add width a bit so you can see we got a little circle. Later, for example, you could change its color when aiming the interactable objects or enemy if you want. When you scroll down your palette under User Created, you can see why I used prefix A. So widgets made by me are the first ones. So drag our bordered box in. Set anchor to middle and set X alignment to 0.5, so when both positions are 0, it touches center point with its top line. Size doesn't matter. Change position Y so there is a space between center point and our box. I go with 150, but this can change later on in development process with adding more UI elements. Add to the slot @item text block. We could set size of the box to fixed value, but I don't know how much text I will be showing in the future, so click to the bordered box and check size to content. Also don't forget to rename text block. I name it TB_interactable text and check is variable so we can edit some logic later. You can see that text is out of the box because we removed padding. If you have more than one monitor, drag default bordered box there or just undock it so you can see text in the HUD, and you can also change padding. When you change value, you must hit compile, otherwise you won't see any changes. I want more space on the left and right than on the top and bottom, so I go with 20 for left and right and 10 for top and bottom. Set what values you feel like look the best. When we write some 2-line text to test it, you can see that the box is changing its size appropriately, but I will also change justification to center. Now to the graph. Create a new function which I name try show interactable info text. Add two input parameters. The first one name show ? and leave it as boolean. Second parameter name text the show, and you can choose string or text, both have pros and cons. I go with text. Add branch which condition is show. If we want to show the text, we must set it to text block. So drag in tb interactable text. Out of it search for set text. Those two do the same functionality, so choose one of them. Connect it after true and in text, connect with text to show. When the text is set, we want to show it. So drag in bordered box. Out of it search for set visibility and leave visibility as visible. Duplicate it below, connect target, change it to hidden and execute it when result of branch is false. I also set the default visibility to hidden, but our approach solves it, so you don't need to. Now back to BP third person character. Move loop for info and disconnect it. First we must create HUD, so at node create widget. As class select WBP HUD. Promote return value to variable and name it HUD. Out of right bin search for add the viewport and after it finally execute loop for info again. Because here is nothing to change in the future, we can clean it up a bit. Select all three new nodes, right click to one of them and select collapse nodes and name it setup HUD. Now move back the loop for info. Move delay to right and drag in reference to HUD. Out of it search our function try show interactable info text and add it in. Connect it before delay, and for now we want just to test that it works properly, so connect return value out of raycast to show. Drag out hit and select break hit result. Here we can see all information we get out of raycast function, but for now I just want to show some text, so I connect location to text to show. It automatically makes conversion and we are ready to test. Hit compile and hit play. You can see that when we don't hit anything, nothing shows up. When we hit anything, text shows up. And when we stop hitting any object, text is hidden again. We have interaction system done almost. Now let's create interactable objects. Go to content folder and create new folder, interfaces. In it create blueprint interface. Again you can add prefix bi or I, but I name it just interactable. Right after you open it, new function is waiting, so name it show interactable information. Add input parameter, name it hit component, and change its type to primitive component. Add output parameter, name it show ? and change its type to boolean. Add another output parameter, name it text to show, and change it to text. Add another function and name it interact. Add input parameter and as in the previous function, name it hit component and change its type to primitive component. Hit compile and go to third person character. Here, move those nodes to right and delete conversion. After raycast, add call to function show interactable information of our new interface. connect its output pins to the ones with the same name. As for input parameters, connect hit component of break hit result with hit component, and the hit actor is the target. And here you can see our completed function. It would be also good to be able to make interaction with another object, so move down a bit. We'll be using enchanted input system later in this series. For now, just search key and add the one you want to use for interaction. I use E key. Now go up to loop for info, copy all raycast related nodes and paste it down to E key event. Connect pressed to raycast. After raycast, add call to function interact, and as before connect hit actor of break hit result to target and hit component with hit component. Now I quickly show you how to create basic interactable objects and how to interact with them. Later in this video, we'll be making proper ones. I just quickly create a new folder for just testing stuff, and in it I create testing actor. In order for this actor to be an interactable object, it must implement our interface interactable. You do it by going to class settings and under section interfaces, you have drop down menu add. Here you can see all interfaces this actor can implement, so you can search for interactable, and here you can see it. When you add it, you can see that on the left side was edit functions of the interface. I just add some mesh, and you can implement those functions by double clicking to them. Here you can implement whatever logic you want. Function show interactable information will be used for showing to the player the text of what will the interaction do, and function interact will execute the logic. Here you can see that I created basic cube which after pressing E key changes its state. I also forget to turn off visibility of raycast, so set the draw debug type to none if you have it as I do. But what if we want to interact just with part of the actor? For this functionality, create function in library tracing named compare components. It doesn't do any tracing, but I will use it only with it, so it's okay I guess. Add two input parameters. First one is hit component, which is primitive component. Second one name BP components, which will be more primitive components, so change it from single to array. BP components will be a set of parts of the blueprint which we want to interact with. Add for each loop. To array, connect the BP components. Out of array element, search for equal and compare it with hit component. The loop body add branch and the condition connect result of equal node. If we found searched component, we can stop looping, so after true add return node. As the result of this function, we want to get which component of the array is the one we want. So take array index and connect it to return node. If this isn't the part of blueprint we are looking for, we want to continue to go through array. So leave false statement blank. If we went through whole array and there wasn't the search component, we want to know as well. So add return node after completed and set array index to -1, which we can't get out of array. We don't change any values in this function, only getting one. So also check this function as pure, which removes execution pins that we don't need. Now let's see how you can use it. I add a few basic meshes to blueprint: cube, sphere and plane. I added them after event begin play, make array out of them, and I promoted the variable. You can see that Unreal recognized that there are static meshes, but because they are part of Blueprint now, they are as well primitive components at the same time. Because approach will be the same for both functions of interfaces, I just change displayed information. First, I add compare components and connect into it the array of our objects. Out of array index, search for switch on int and execute it after function starts. I add pins for each object and connect to them appropriate return node. Default pin is for each number which isn't added as separate pin, so it's for all negative and higher numbers. We want return node for all possibilities, so add return node to default pin and just uncheck show. When we test it, you can see that when I aim the base, nothing shows up, and for each mesh is displayed appropriate text, even it is one actor. Now let's create proper interactable item. Good example is one you use in your life in daily basis. I'm talking about door. So we'll be creating a sliding door, and to make it more interesting, it will be opened with a lever. But because we don't have 3D model of it, let's go into Blender and quickly model it. If you want to follow my steps, just make sure in Preferences under Input you have checked Emulate 3-button mouse. This option lets you select connected parts by double-clicking. First, let's create the door and frame in which the door will be set. Shift A, Mesh, and add Cube. Open Detail panel by clicking to the arrow here, or by pressing N key and set size of the door. I set X to 5, Y to 0.5 and Z to 3. Switch to Edit mode, press 3 for selecting faces and select the bottom face. Shift S, cursor to selected. Switch to Object mode, right click on the door, set Origin and select Origin to 3D cursor. Shift S and cursor toward Origin. Shift S, selection to cursor. Ctrl A for apply and select all transforms. Now it's positioned to right and set for future exporting to Unreal. Switch to Edit mode and add 10 cm, which is 0.1, to all narrow faces. So select face, press G for move, lock axis, in this case by pressing Z or X, and write 0.1, positive or negative. Or after selecting a face, change appropriate value of median. Now the door is done for now, so duplicate it by pressing Shift D and right click. One object renamed the door, I add _01, the second one renamed the door frame and hide the door. Select the large faces, press I for inset, scale it down a bit and press 2 for selecting edges. Select 2 top lines and set Z in median to 3. Bottom ones set to 0. For side lines set X to 2.5 and -2.5. Select middle faces on both sides, press X for delete and select faces. Now we got groove in which the door will slide. Because this will be the inside part that you can see, normals are wrong. You can check them by clicking here and turning on their visibility. Those blue lines show direction of normal. In Unreal, it would be transparent if you wouldn't use two-sided material. To fix it, select all faces, Alt-N, and select Recalculate Inside. Turn off displaying normals. Select inner edges, E for extrude, and right-click. Since thickness of the door is 50 cm, I decided that the door will be thick 1 meter, so set Y to 0.5. E for extrude, right-click, S for scale, and scale it up a bit. Repeat the same process for the other side. Select both edges on one side and set X to 4 and -4. The top edges set Z value to 3.5. Bottom edges just have to be lower than the groove is, so set Z value to -0.2. Now let's finish it, so while you have selected two opposite edges, press F for fill. All you have to do now is select one edge facing into the blank space and press F key 3 times. Because we fixed normals earlier, all new faces have correct orientation. Why did I make the groove? When the door will be sliding, it looks a bit better, and because the groove goes to all sides, the door can move to all sides as well. I just select outer parts of groove and hit Ctrl B for bevel tool to lower sharpness. And I do the same thing for the door. Now the door and the door frame are done, so hide them. And let's create the lever and its frame. First, let's create the frame. Shift A, Mesh, Cylinder. Open details of edit object. I want it more rounded, so set vertices to 64, radius set to 0.25 and the depth set to 0.2. Proportions look alright, so continue. R for rotation, Y for locking axis and right 90. Ctrl A and apply all transforms. Switch to edit mode and now we create a groove in which the lever will be moving. Select all faces except those two side circular ones. I for inset. 10 cm groove looks too much to me. 6 cm looks good, so it's 0.03 for both sides. Select side faces and remove them. Press 3 on numpad, turn on X-ray and select all vertices below green line. Press X and remove vertices. Select all vertices on one side and press F to fill. Do it for the other side and for bottom side as well. Now we have to decide how large the groove is going to be. The fifth square looks like the best place to start, so select it. Press numpad 1 for front view, turn on X-ray, select all squares from top to the selected one, press X and delete those faces. Press 1 to switch to selecting vertices, select all inner vertices on one side, press F to fill, and repeat for the other side. Select inner square and fill it as well. E for extrude and right click. S for scale, Y for locking axis and scale it down so there is a bit of flat area. E for extrude and push it down. Select inner edges and add bevel by Ctrl B so edges are not that sharp. I write 0.001 and do the same process for outer edges except the bottom ones. I also turn on Auto Smooth so it's smoother. Rename the object the lever frame and move to the lever itself. Shift A, Mesh and add cylinder. Press R and Y and rotate it by 90 degrees. Ctrl A and apply transforms. Numpad 3 to side view, turn on X-ray and switch viewport to wireframe. S for scale and scale it down so it's smaller than the flat area on sides and it's bigger than the bottom of the cavity. Numpad 7 to top view and scale it along x-axis so it's slightly thinner than the groove is. Select all side edges, Ctrl B for bevel tool, and I use value 0.01, so now the wheel will be visible at a glance. Shift A and add cylinder. Numpad 7 to top view, turn on X-ray, S for scale, and scale the cylinder down so it's smaller or same size as the unbeveled part of the wheel. Numpad 3 to side view, G for move, Z to lock Z axis and place it so top of it is above the top of the wheel. Adjust height if needed and Ctrl B for bevel so there is smooth transition to rod. Select middle face, E for extrude and drag it up. Median Z 0.35 works for me. E for extrude and right click. Numpad 7 for top view, S for scale, and I make it the same size as the base part. Numpad 3 for side view, E for extrude, and set Z median to 0.6, so the handle is pretty big. Select top circle and outer edges of handle. Ctrl B and bevel these edges. Rename it to lever and you can also add auto smooth. For now, we will be using Unreal default materials, so make all objects we've done visible. While you're in object mode, press A to select all objects and switch to UV editing tab. Hover over right side and press A to select all faces. Move your cursor to left side and press A to select all as well. Go to UV, Unwrap, and select Cube Projection. Expand the details and set cube size to 1. This way all default materials in Unreal will look the same size, and I find this approach the best for prototyping with materials. Last is exporting of these objects to Unreal. You can export them as one file, but I export door and lever separately. So I select the door and frame. Now go to File, Export and select FBX. Name it appropriately, check selected objects and hit Export FBX, and I repeat the process for level as well. Before we leave Blender, I also create a new collection for door and lever and move into them those objects, so when I make another 3D model, I can make it here and I can turn on and off visibility of already created objects, for example for size comparison. Save your Blender file and back to Unreal Engine. I create a new folder and name it just props. Drag in FBX files, select Do Not Create Materials and click the Import All. Now open all imported static meshes and first we want to add to them materials. So open Content Browser, go to Starter Content and open Materials. For door, I like sandstone material, so I clicked it, and by clicking to this icon of left going arrow, you can assign selected material to a material slot without needing to drag them into it or repeatedly searching for it. So assign it to door frame and door. You can use some metallic material to lever and lever frame, but I like rock bezeled. The second thing we need to do is changing collisions. Automatic collisions create the simplest convex collisions, so now you are not able to go through the door frame. For low poly objects, such as the door frame, just scroll down in details the collision section and change collision complexity to use complex as simple. For higher poly objects, it's better to create collisions in Blender or add collisions in Blueprint. I do the same change for lever. Other objects are okay, so you can close those tabs. Go to Props folder and create a new Blueprint class of actor. Name it BP Door and open it. This will be a parent class to all doors we can use and will contain generic functionalities that all doors should have. But what are these functionalities? For me, it is capability to open or close and toggle between those states, and capability to lock or unlock. I also want to know if the door is in motion, opening or closing, and in what state the door is currently in. We use inheritance, so no matter how we implement those functions, we can always just cast and call parent function. So let's do it. Go to Event Graph and add custom events. Name them Open, Close, Toggle, and Close and Lock. You can add Unlock and Open and implement it by yourself. I will add it later. Now add variables. First one is open of Boolean type. Second one I name opening/closing of Boolean type. And the third one name isLocked and its Boolean type again. Variable isOpen indicates state of the door. If it's true, the door is opened, and if it's false, the door is closed. Variable opening/closing indicates if the door is in process of opening or closing. In other words, if the door is moving. And isLocked indicates if the player can open the door. Events open and close will manage the door animation and changing variables. But toggle will be the one we will be calling the most, because if the door is closed, we don't want to close it again. We want to open it. And close and lock event can be used, for example, when the player enters the boss area. This function will be called and the player can't escape. Now to the door controller. Open Content Browser and create new blueprint of actor class. Name it BP_DoorOpener and open it. Go to Event Graph and add one custom event Use that will contain animation and call to the door function toggle. Add variable inUse of Boolean type, which fulfills the same logic as opening/closing in door blueprint. Add another variable, name it door, and change its type to BP door. Lastly, go to class settings and add interface interactable. Finally, hit compile. Open Content Browser, right-click the BP Door Opener and select Create Child Blueprint class. I name it BP_lever_01. Also, you can rename imported static meshes if you haven't already. I just remove name of the FBX file. Now open BP lever 01 and drag in lever and its frame. The lever looks good, but it could be unnecessarily hard for a player to interact with it because it's thin. We can solve it by selecting the lever, clicking the Add button and adding Capsule Collider. Now just rename it the Lever Collider, adjust location and size. Because this collider is only for interaction, scroll down and under Collision select Custom. Change all collision responses to ignore, but trace responses set to block. Now to the event graph. First, Let's implement interact function, so double click on it. We want to execute interaction only when certain circumstances are correct, so add branch. To the circumstances. We want to interact only with lever collider, so drag it in. Out of hit component, search for equal and connect lever collider to the second input pin. We also don't want to do another interaction when the lever is in use. Right click and search and add get in use. And we want when it's not in use, so add date not boolean. Branch must be true only when both statements are true, so add end boolean and connect it. If the branch is false, nothing happens, and if it's true, call function use. And event interaction is done. Now to the use function. Go to left panel Functions, Override, and click on Use. When it is in use, it is in use, so search for set in use and check it to true. After that, add timeline and name it lever rotation. I will be returning my lever to initial position, so connect set in use execution pin to play from start and open the timeline. Change length to 1 and add float track. But what values are we changing? To get the answer, go to viewport and select the lever. I don't want the initial position to be in the middle, so switch the rotation and rotate it the corner of the groove. The axis along which we are rotating can be different according to the direction from which we modeled the object. We can see that X rotation value is changed, so go back to timeline. Rename track to lever X rotation. Right-click and add key. Set time to 0 and value to initial rotation value, which is in my case -60. I want the lever to be quickly pulled and then slowly released, so add another key, set time to 0.1 and value to 60. Now we want to get it to the initial state, so add key, set time to 1 and value to -60. For command to open the door at track, select add event track and name it use door. Add key, I don't know if value does anything, so I set it to 0 and set time to 0.1 and go back to event graph. First, we want to animate the lever, so drag in its reference and out of it search for set relative rotation. Connect it after update. Right-click the new rotation and select split struct pin. Connect lever X rotation to new rotation X, and we can leave Y and Z values at 0 because we didn't change them. When the animation is finished, the lever is no longer in use, so after finished, add set in use, which is unchecked, so it's false. To the use door pin, right-click and search for get door variable, which we added in BP door opener blueprint. Out of it, search for toggle and connect it after use door. And we are done with use function. Now let's implement second function of interactable interface, show interactable information. We will use the same condition logic as for the interact function, so move up and copy it. Go to show interactable information, paste it and connect it. Duplicate return node, connect one with true and second one with false. The one connected with false must have been show ? Unchecked. The return node after true statement, check show ? pin to true and write appropriate text to text to show. I write there, press E to use. We are done here, so hit compile, and the last thing we need is the door. Open Content Browser, and similar as with the lever, right-click the BP door and create child blueprint class. I name it just BP_door_01 and open it. Drag in door meshes and BP lever. Position the lever to the one side. You can see my final transform on the screen. Duplicate it, inverse location X and Y. Rotation Z sets the -180, and now it's mirrored on the other side of the door. Now we must set the reference of this door to the levers. To do it, go to construction script. We have nothing in parent class, so we can delete inheritance here. Drag in levers, so we can get reference to them. We have only 2 levers here, so you can do it one by one or in a simpler way that I show you later. For now, add for each loop, and out of array, search for make array. Add one pin and connect them with levers. Now it's a bit tricky. Right-click in the open space and search for get child actor. None of the options we see is the one we are looking for. We have the unchecked context sensitive, and the one we are looking for is get child actor under child actor component. So select it and to the target connect array element. Drag out child actor pin, turn back context sensitive, search for cast to BP_door opener, and connect it with loop body. Out of SBP door opener, search for set door, add it in, and connect it with the first execution pin of cast. Drag out input pin of set door and add self-reference. This way you can set reference of a blueprint to its child components. Now let's implement functions of the door. Go to Event Graph. As with the lever, add our function one by one by going to override and selecting them. So add open, close, close and lock, and toggle. Before we start any animation in timeline, it's good to change variables to the appropriate state. Start with open. When we open the door is opened, so add set is open and set it to true. We are about to start animation, so add set opening/closing and set it to true as well. Copy it, paste it to close and connect it. When the door is closed, it is not opened, so set is open to false. To close and lock, add set is locked and set it to true. After that, you could paste same sets as with close, but this is the same as after close. Instead, we can avoid redundancy by connecting the execution pin of set is locked to set is open in close. Add timeline and name it open/close. Event open goes into play and event close goes into reverse. If you'd want to have some doors start as opened, connect it to play from start and reverse from end. Open timeline, add float track and name it door Z location. Add key and set time to 0 and value to 0. Because the default height is 300 and the groove height is 10, value of opened door is -310. So, add another key, set time to 5 and value to -310. Back to Event Graph. Drag in door reference. Out of it, search for set relative location and connect it with update. Split struct pin of new location and connect door Z location with new location Z. After finished, add set opening/closing and set it to false. Now go down and let's implement toggle function. First, we must check if we can toggle the door state, so add branch. We need to check if the door is unlocked, so add getIsLocked, and to it add not boolean. We also want to change the state of door only if the door is not in the changing process, so add getOpening/closing and add not boolean as well. We want to change state only when both statements are true, so connect them into AND boolean and connect it into condition node of branch. When the branch is false, we want to do nothing, so leave it blank. After true, add another branch that will decide if the door should open or close. So add getIsOpen and connect it into condition. When the door is open, we want to close it. And when the door is closed, we want to open it. We are almost done here, so we can test it. Add the door blueprint to your level and I move it a bit up so bottom doesn't flicker and hit play. Go to the lever and press E. The door is going down and you can go through. Press E to the lever and the door is closing. By the implementation that we did, you can use lever multiple times, but only when the door stops moving, it does something. Now let's take advantage of inheritance. Go back to BP door 01 and move up. All initial changing of variables will be same for most of the potential doors. So, select all sets between events and timeline, Ctrl X, go to BP door, paste it and connect it. Go back to BP door 01. Because we used override of functions, the code we inserted into the parent class isn't here yet. We access it by right-clicking to event open and selecting add call to parent function. Take new parent open node, connect to it event open and connect it to play. Repeat the process similarly for close and lock events. Now to the toggle. We can see that this implementation is generic and doesn't contain anything for this door only, because it's only about switching states of the door when conditions are met. So, select all the code except event toggle, Ctrl X, delete event toggle, go to BP door, paste it to toggle and connect it. Now to how we can use inheritance to make easy adding other functionalities. We have function close and lock, so let's implement function unlock and open. Add custom event and name it unlock and open. We could do it as with close and lock. Add setIsLock, uncheck and connect it to setIsOpen of open event. But locking and unlocking doesn't have to be so easy in all cases. For example, what if we want a door that needs a key to open, and we don't always want to open the door after it is unlocked? For this, it is better to create a new function, unlock, and add isLocked with false. Now it's working and we can override it in future cases. Add new function lock, add setIsLocked and set it to true. Go to event graph and replace setIsLocked for unlock and open with unlock function, and isLocked for close and lock replace with lock function. Hit compile and go back to BP door 01 because we added a new function. Go to functions, override and select unlock and open. Move it above event open, right click, add call to parent function, connect it with unlock and open and connect it to play. Hit compile and let's check that it still works. Sometimes when you move bunch of code, you might forget to reconnect something, so it's better to test it right away. Everything still works. Now let's clear up the files, so in folder props are parent blueprints and child blueprints are in their files with their meshes. Open Content Browser and save all, because while moving files, sometimes you move what you shouldn't and Unreal crashes. Create a new folder and I name it Stone Door. Move into it bpdoor01 and static meshes of door and its frame. Create another folder called Lever and move into it bplever01 and static meshes of lever and its frame. Now just let's quickly look how easy it is to make a door that opens in other directions. I take bpdoor01 and rename it to bpdoor down. Duplicate it and replace down with up. Open it, go and open timeline open/close. Select second key and remove minus from value so it's 310. Now if we test it, you can see that the door goes up and it's in line with the groove as well. Don't mind the overlapping of the floor and the door going into the air, because in proper game level you wouldn't see it. Similarly, we can do side going door. In this case, we need value of sliding to the side, that is plus or minus 510. Go and open timeline open/close, rename track to door X location and change the value to minus 510. Now go back to event graph, disconnect connection leading to new location Z and connect the door X location with new location X. Hit compile and go to level preview. Here I place the door to side wall, so it's like in the game where we wouldn't see where the door is sliding to. So let's test it. And it's looking good. Now to the part that I promised you earlier. In many cases, you don't want to have lever as part of the door, but you want to place it in your level. For this, duplicate blueprint of slide door and add to its name _no lever. Open it, go to construction script, delete all code here, and delete levers. Hit compile and open BP door opener. Here, just make variable door public and hit compile. Place the new door into your level, as well as levers. I place one on wall here, and second one here. When you have selected lever, you can see here variable door. You can search for the door or just click the picker icon and pick the door. Don't forget to do it for both levers. If you don't want to make variable of lever door public, you can assign door to the lever in level blueprint. So, we have finished the interaction system for now, and you should be able to create at least basic interactable items on your own now. Last thing I do is clear the level and delete testing objects. If you found this video useful, give it a like, and if you don't want to miss next episode, subscribe. Thanks for watching and see you in the next episode or in another video.